Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're doing here is we're going through a kind of series on verifying some frequently asked problems in both mathematics and chemistry topics. So this ranges from, if you're tuning in from Ontario, the grade 9 to grade 12 curriculum, and if you're tuning in from the US, it's from the pre-algebra all the way up to the pre-calculus kind of curriculum. And what my job is, I'm going to look over the questions and look over the solutions. And what my goal is to provide, to first verify the solution to see if it's correct or not, and then afterwards provide the best possible solution moving forward and teach you the concept behind the question through the solution. Again, my name is Joey. I'm currently an Ontario school educator with OneClass, and my teachable subjects or my subjects of interest are chemistry and mathematics. So let's get started on today's problems. I have about 10 problems for us today, and we can go through those together here. So first question is asking, what is the square root of 6 in simplest radical form? So let's look at number 1 here. It's question 1. We're looking at square root of 6 in simplest radical form. So what we have here is we want the square root of 6. So we're going to draw the square root sign. We're going to put the 6 in underneath. And what they want us to do is to calculate the simplest radical form. Well, in this case, if you take out the factors of root 6 here, we know that root 2 goes into 6 and root 2 times 3 is going to equal 6, right? So in this case here, this here will be the simplest radical form of this radical here. So it's actually, root 6 is actually the simplest radical form in this case here, because we can't find any other factors that are not prime numbers. 2 and 3 are both prime numbers here, so root 6 is definitely the simplest radical form. However, what we can do in this solution here, what they did was they actually found the approximate value of what root 6 is. So let's take a look at the solution here. And what we can do is we want to find an approximate value for the square root of 6. So it's going to end up being a decimal because root 6 is not a perfect square. So what we're going to do is we're going to use a long division kind of method here. So we're going to put 6 as the dividend here. And what we want to do is we want to find two numbers that square closest is 6. And in this case, it would be 2, right? Because 2 squared is 4. And 3 squared is 9. But we can't go over 6 here. So we're going to put 2 and 2 here. We'll put 2 here. And then, so we know that 2 squared is 4. So we can put 4 here. And then we're going to subtract this to get 2. What we're going to do next is we're going to double this number. So this becomes 2 times 2 here is going to become 4. And then we can add 2 zeros here as well. So you can think of this as 6.0000. We're adding 2 zeros here. And then we're thinking of a number from, sorry, let me make a little bit of space here. We're thinking of a number that's in a 40 digit that's going to be multiplied by the same number to get closest to 200. So you can think 41 times 1, 42 times 2. So let me take out my calculator and might be able to solve this a little bit easier here. So 41 times 1 is 41, obviously. what's 42 times 2 would get me 84. 43 times 3 would get me 129. 44 times 4 gets to 176. And 45 times 5 would give me 225. So 44 times 4 is the closest without going over to 200 here. So we want to put a 4 here and also a 4 here. So this is going to be 0.4. 44 times 4 is 176. Subtract those two numbers, we get 24. And what we can do again here is we're taking this number, the last digit, we're going to double the number here. So this becomes now 48. And then we're going to add 2 more zeros here. And we want one more decimal here. So again, I'm looking for a number here. These two have to be the same numbers that multiply closest to 2400. So let's do, I'm going to start from 481 times 1 is 481. 482 times 2 would be 964. 483 times 3 is 1449. And then 484 times 4 is 1936. And I believe that I can't do 48 times 5 because that just goes over by 25. So our number here is going to be another 4. So 484. And then 484 times 4 is 1936. Again, we can actually keep doing this process over and over again to find out the other decimal number, but we usually stop at 2 here. So in this case, what we can then verify is that root 6 is going to equal basically approximately this number. So it's approximately plus or minus 2.44. Remember, every time we take a square root, we also have to do plus or minus to determine, because both 2.44 and positive 2.44 plus times 2.44 is about 6, and negative 2.44 times negative 2.4 would equal 6 as well. So this solution is correct because the square root of 6 is equal to plus or minus 2.44, like we said. So the solution here is correct. All right. Let's look at the next question here. This is number 2. And we're looking at 0.9 here as a fraction. So again, we're going from, this is from a decimal, so 0.9 is a decimal as indicated by this decimal point, into a fraction. So how do we convert a decimal to a fraction? Well, it's very, very easy. And what we can do firstly is we can look at the giveaway here is the decimal in itself. So if you look at the decimal here, I have 0.9. As you can see, this 0 is the whole part. So it's a 0, so we don't care about it. But we care about this decimal part here because this is going to make it the fraction part. And again, as you can see, this 0.9 is in the tens digit in the decimal. So our denominator, is going to be the denominator of 10, and the numerator is simply whatever the decimal is. So in this case here, this guy here is 9. So in this case, 0.9 equals 9 over 10. And this here is our answer for this problem. I can't not reduce 9 over 10 into its lowest terms because 9 and 10 there's no greatest common factor of 9 or 10 here. It's just itself here. So in this case, we don't have to reduce. So we say therefore 0.9 as a fraction is 9 over 10. And this here is our solution for this problem. And this here, as you can see, 0.9 and 10. 0.9 is 9 over 10 as a fraction. This solution is correct. Let's look at question 3. Asking us, what is the factors of 48? So if we're looking at the factors of 48 here, we're basically we're going to look at, it's very, very similar to what prime factorization is in square roots. So we're looking at 48 here. And we can see that we want to break this down into its prime factors. So as you can see, 48 here is a pretty good number because it's an even number, which means I know that 2 must be a factor of 48. So I can take out a 2. And then what I can do is I can divide 48 by 2. And 48 divided by 2 is equal to 24. And then what I can do is I can do the exact same process with the next biggest number. So again, I take 24 here. I look at the number. This here is an even number, which means 2 must also be another factor. And then 24 divided by 2 would be 12, right? So this here would be 12. And then I take a 12, and I can, again, break that down into, I realize that 2 is, again, it's an even number, which means 2 must be another factor. So I can break it down into 2. 12 divided by 2 is equal to 6. And then finally, 6 here can be broken down into, again, I know that 6 is an even number, which means 2 must also be a prime factor. And then 6 divided by 2 here is equal to 3. And now we stop here because 3 is a prime number in itself. So therefore, the factors of 48 are, so we have 2, 2, 2, 2, 3. So we can say what we can do is we broke this into its prime factorizations, but with 48, what we can do is we can actually, the factors of 48 also include whatever the multiplications of these guys are. So factors of 48 are as follows. So I have 2 and 3 here. 2 times 2 is 4. 3 times 2 here is 6. 2 times 2 would be 8 again. And then I would have 2 times 2 times 2, which is 8. I have 2, or yes, I have 2 times 2 times 2 times 2, which is going to be 16. But I also have 3 times 2 times 2, which is going to be equal to 12. Or sorry, 3 times 2 is, no, 16, sorry, 16 is not. Yeah, 16 is the factor, sorry, because 16 times 3. And then finally, I have a factor of, let's see, 2 times 2 times 2 times 2, which would give me, sorry, a factor here would be 24 as a factor as well. So this here is also a factor. So these are all my factors of 48. 2, 3, 4, 6, 8, 12, 16, and 24. And these are all the factors of 48. So this here is the correct solution. Again, they gave us the prime factorizations, but they actually didn't give us the specific factors here, because they did ask us what the factors of 48 are. These are the prime factors, but they're not specifically the factors here. So the solution is correct for the prime factors. And I can say the following is the factors for 48. Simply multiply the prime factors to itself. So I can say it's 2, 3, 4, 6, 8, 12, 16, and 24. These are all the factors. So this solution here is correct. That's number 3. This is number 4 here. 4 is asking us find the zeros, multiplicity of zeros for the for the given expression. So f of x is equal to 4x to the power of 7 plus 40x to the power of 6 plus 100x to the power of 5. So we first want to find the zeros. So how do we find the zeros? Well, what I wanted to do is I want to solve for this x value here. So how do we do that? Well, this is to the power of 7, so we can't, there's no specific type of form that we have to use. But what we can do here is we can factor firstly. And what we can do here is we're basically setting this guy to 0. F of x has to be 0 to find, to solve for our zeros here. So we're going to set this to 0 first. And we can think of it as solving for the x-intercepts or zeros. They're kind of interchangeable terms here. And then what we can do here is we can look at these 3 terms. Do we have a common factor? Yes, we do, right? Common factor here is x. So I can say its common factor is x, but what is the degree of the common factor? Well, I have x to the power of 7, x to the power of 6 is x to the power of 5, which means I can actually take out x to the power of 5 here. So my variable is I would take out x to the power of 5, but I can also take out a number, right? Because as you can see, if you look at the constants here, only the constants, I have 4, 40, and 100, which means the greatest common factor of these guys, all 3 terms, is going to be 4, because 4 divides into all of these guys here. So I'm going to have 4. So I have 4 to x to the power of 5. I can common factor that entire term. And then I'm going to get, let's see what I'm going to get. I'm going to get here x. I'm going to be left here with x squared, because I have x to the power of 7 divided by x to the power of 5, which is x squared. Plus, and then I have 40 divided by 4 here, which is going to give me 10. And then x to the power of 6 divided by x to the power of 5, which would just give me x. And then 100 divided by 4 is going to give me 25, right? And the x to the power of 5 and x to the power of 5 canceled out. So now we have, this is an easier expression, right? We have 0 equals 4x to the 5. And then we have this trinomial here. And this trinomial is actually really good. It's an example of a perfect square trinomial. Because I have a 25 value here, which is a square root of 5, and 5 times 2 is equal to 10. So this here is an example of a perfect square trinomial. So if I factor this, or this is going to give me x plus 5 squared. So now what we can do is we can actually take both cases here. We can break this down into, this is case 1, and this here is case 2, and we can set it to 0 to find our zeros, right? So for case 1, 4 to the power of x to the 5, or sorry, 4 times x to the power of 5 is equal to 0. Divide 4 by both sides, I'm going to get x to the power of 5 is equal to 0. And then finally, if I fifth root both sides here, it's going to still equal 0, right? So x to the power of 0 is definitely a factor. And then for this guy here, if I set x plus 5 squared equals 0, what I can do, again, I can square root both sides, so I'd get x plus 5, which equal to 0, and then I can simply subtract 5 for both sides, so we get x would equal negative 5. So my two factors here are x to the power of negative 5 and x equals 0. So as you can see, zeros are 0 and negative 5, which is great. So we've solved for these zeros now, and now we have to solve for the multiplicity of these zeros, right? And how do we solve for a multiplicity? Well, we simply look at the we look at our zeros here and see what what is being defined here. So we can say that we set our equation to 0, right? We have 4x to the power of 5 times x plus 5 squared. And we can plug in these zeros back, right? We could say that 4 is this x value is going to be 0 to the power of 5 times x plus this here is negative 5 to the power of 2, right? And in order for us to find multiplicity, we simply just look at the degree of these zeros. So in this case here, this is x to the 5 here. So x equals 0 will have multiplicity of its degree, which is simply just 5. So as you look at the 4x to the power of 5 term, as we solved in our previous solution here, x equals 0 for this term. So we can say the x equals 0 has a multiplicity of 5 here, because this is x to the 5, and x equals negative 5 will have a multiplicity of its own separate degree, which is x to the power of 5 to the is x plus 5 is to the power of 2, right? So this here would have a multiplicity of 2, so its own degree. So in this case here, these are our answers, right? So zeros are 0 and negative 5, as we solve here. And the multiplicity of 0 is 5, which is good. And multiplicity of negative 5 is 2, as determined by the degree of those polynomials. So this solution here is correct. All right, that was number 5. Let's look at number, sorry, that was number 4. Let's look at number 5, sorry. Let's ask us, how do you find the square root of 17? So in this case, again, what we want to do here is we want to first check if it's a perfect square. And in this case, we know it is not a perfect square because 17 is a prime number. So if I take the square root of 17 here, again, the square root sign, and 17 inside of it, we notice that this here is not a perfect square because 17 here is a prime number. So therefore, we cannot use the guess and check method. We must use the long division method. But let's solve for this. So we have to use long division. So put 17 in the inside. So again, two numbers squared closest to 17. I'd pick 4 because 4 squared is 16, right? So we have 4 here. 4 squared is 16. Subtract both sides. 17 minus 16 is 1. I can add 2 zeros to this guy here. And then what I can do is I can double this 4, and this becomes 8, right? And I have to find what value should I put here to be closest to 100. So 80 times 0 is 0, but 81 times 1 is equal to 81. 82 times 2 is 164. So that goes over 100. So this value must be a 1. And again, I have the decimal here. 81 times 1 will give me 81. So you have 100 minus 81, which goes 19. Add another 2 zeros. I can double this number now. 81, I double this number. So 1 plus 1 is 2. So I have 82. And then I have to find out another value here. So what would go in this blank? Well, 82 times 1 is 821. 82 times 2 would give me 1644, which I believe is the closest to 1900. So this value must be a 2. So this is 1644. Subtract those guys, I would get 266. Or sorry, 256. And again, I would usually stop there because I usually take these guys to the 2 decimal places. This solution is actually really nice because it actually gave us a little bit more, but I usually take it to 2 decimal places. So therefore, I can say the square root of 17 so I can say, therefore, square root of 17 is approximately equal to plus or minus 4.12, not 71, 4.12 here. And this here is our solution for this problem. And again, they got 4.1231, which is our correct solution as well. So this solution is correct, but I don't think they actually gave us a concluding statement. So I'm just going to write it out for them. It's correct. The square root of 17 is approximately plus or minus 4.12. So the solution here is correct. Let's look at number 6. So number 6 is how many seconds are in a 24-hour day? So what we can do here is we can use this concept of unit analysis for us to solve this problem here. So let's look at some conversions that we need to know first. So we have so these are some conversions. So in a day, how many hours are in a day? So we're going to take our biggest value here, which is a day, and then we're going to try to we're going to write out the conversions for it as well. So in one day, I have 24 hours, right? And then in 1 hour, I have, well, how many minutes in an hour? I have 60 minutes in an hour. And then in 1 minute, how many seconds do I have in a minute? Well, I have 60 seconds in a minute. So these guys are going to be my conversions for this value here. So it's asking us, well, in a 24-hour day, how many seconds are there? So let's look at how we solve this problem. Well, in one day, we use this concept of unit analysis. So in one day, I'm going to multiply it by, I know I have 24 hours in one day. And then I'm going to multiply that by, I want to convert now hours into minutes, right? So in 1 hour, I have 60 minutes. So I have 60 minutes in 1 hour. And then I can say, well, how many seconds do I have in a minute? Well, I have 60 seconds in 1 minute per 1 minute. And once we see these seconds, we can stop here because it's asking us what are the seconds here, right? So as you can see, these units cancel out. The days cancel out here. The hours cancel out. The minutes also cancel out. And we're left here with seconds. So all we're doing here is we're multiplying. Let me do this back in purple. We're doing 1 times 24 times 60 times 60. And this will give us how many seconds in one day. So 1 times 24 is 24 times 60 times 60. 24 times 60 will give me, let's see, 24 times 60 gives me 1440 times 60. And this is going to give me a value of 86400. And this is going to be seconds. And as you can see, that's the correct answer that I got here, which is nice. So therefore, I can say in 24-hour day, there are 86,400 seconds. And this is our solution for this problem. So this solution here is correct. They didn't use unit analysis like I did, but this is also a valid form because they actually broke this down into 1 day they went from hours to they went from hours to minutes first and minutes to seconds, and then they went backwards and they did days to hours. It doesn't really matter about the order because when you're multiplying kind of values here, integers or real numbers here, the multiplication is commutative, so it doesn't matter what the order you do. What's the order for multiplication? So the solution here is correct. Number 7. I think I did this problem in the previous stream. It might have just repeated itself. There's a lot. Some problems actually tend to repeat themselves because they're commonly asked problems. So I guess I'll do this problem again. 2, 3, 4, 5, 6. This question 6 or 7. Let's see. 1, 2, 3, 4, 5, 6. This is 7 here. It's asking 0.9 as a fraction. So again, we're converting from a decimal to a fraction, right? So what we can do here is I have 0.9. And as you can see, the whole part is 0, so I don't care about it. But I care about this part here, because this part, 9 is in the tens digit. So you can say that the denominator is going to be 10, and the numerator is simply just the decimal. So whatever is in the place, which is going to equal 9. So this here is our fraction for 0.9, right? And again, 9 over 10 is the reduced form, so we don't have to reduce this any further. So therefore, I can say 0.9 is 9 over 10 as a fraction. And so this solution here is correct. And again, as I look here, it says fraction value. Here, 0.9 is the value that can be written in the form P over Q. So it's 9 over 10. So the solution here is correct. Let's look at number 8. Number 8 is asking us to find coordinate graph. So in a coordinate graph, what do we have? Well, in 2D space, I'm going to assume this is 2D space here. But this would apply also to 3D space, but 3D space gets a little bit more complicated. And it's kind of beyond the scope of kind of mind learning as well. So I'm just going to assume that this here is going to be in R2, so in 2D. So let's look at the coordinate graph here. So I'm going to have some type of x and some type of y, right? So this here is our x value, y-axis, and this here is going to be the coordinate graph. So in a coordinate graph, well, what can I tell? What do I know about the coordinate graph? Well, in coordinate graph, as you can see, I have 4 quadrants, right? This here, we start from this upper right side, so we have quadrant 1. So I wrote, right, this is Q1, this is quadrant 2, this is quadrant 3, and this here is quadrant 4. So what else? What are some other features of a coordinate graph? Well, this here, if this point here, the intersection between x and y is 0, 0. If I go further increase x here, this here would be 0 and positive x. If I go towards the left here, this is positive x and 0 and 0. If I go further to the left, this will be negative x and 0, and some type of y. Actually, no, let me not put y here. So this would be plus x. Actually, let me do sample points, because sample points are a little bit easier to notice. So for example, I'm going to do 4 points here. So let me just do, so if I had a point in this quadrant here, in quadrant 1, what does this tell me? Well, in quadrant 1, I can say this here is a positive x value. So it's here a positive x value and also a positive y value. So this here is the x. So I would have a positive x, a positive y. However, in this quadrant, if I look at this quadrant here, this point would have a negative x, right? Because this would be less than 0 here. This would be negative x, but still would be a positive y. In this quadrant, I would have this guy would be a negative x still, because again, it's past this to the left of x. And in terms of the y, this is also a negative y, right? Because it's below 0 in terms of the y. And then finally, this point here would have a positive x value because it's to the right, and the negative y value because it's below this point here. So again, we have 4 different points here, 4 different quadrants, and this is how we define a coordinate graph here using these guys here. X's can be positive or negative, and y's can also be positive or negative, and you can see which quadrants they lie on. And you can plot functions, and you can plot other data in a coordinate graph here. So again, this solution here is correct. As you can see, 4 quadrants, so 1, 2, 3, 4, y-axis and x-axis, and the origin here is 0, 0. I went a little bit more in depth, and I told you the signs, if it's plus or minus for each of those quadrants. So, but this solution is also correct as well. Okay, let's do number 9. Number 9 is asking us convert 100 milliliters into cups. So what I can do here is I'm looking at some type of measurement, right? I have milliliters and cups here, which means I have 2 different systems. Both systems are measuring this volume. However, I have to do a unit conversion here because milliliters is going to be in the metric system, and I'm going to cups, which is actually the empirical system. So I have to find some type of conversion rate between these 2 systems. So we can say that. So we can say in terms of our conversions, we can say that 1 milliliter is equal to 0.004222675 cup. So based off this conversion, what we can do is we can now convert 100 milliliters into cups. Again, this you don't basically have to memorize because this here is a conversion between systems, and it's not something that's like easy to memorize. So in this case, a lot of times what we do is we actually just give you the conversion rate here. So given this conversion here, how do we convert this to cups? Well, it's very, very easy, right? I can say that using unit analysis, I have 100 milliliters and I want to get cups, right? So 100 milliliters, I'm going to multiply that by 0.004222675. Cup, and then this is per 1 milliliter, right? So I can say is I can actually cancel out this milliliters, and then I can actually just simply do this operation here. So this will give me how many cups I have. So I have 100 times 0.004222675. So if I multiply by 100, I can simply just move the decimal place 2 places to the right, right? So this would mean my new decimal point. So this is 0.4222675 cup. So I can say therefore 100 mLs is equal to 0.4222675 cups. So this solution here is correct because they wrote 42267, so they just rounded here. So the solution here is correct. And then finally, let's look at our last problem of the day. This is number 10. So number 10 is what is true about the sum of the polynomials 3a squared b, or 3a squared times b plus 4ab squared and 7a squared b minus 2ab squared. So this is number 10. So I want the sum of those polynomials. So let's just add those up first. So I have 3a squared b plus 4ab, 4ab squared plus 7a squared b minus 2ab squared. So again, what we can do is we look at our common terms, right? We want to gather some like terms here. So as you can see, 3a squared b is a common term and 7a squared b is a common term. And I have 4ab squared and negative 2ab squared. So these are all common terms, like terms. So I'm going to gather them. So I can see I have 3 plus 7. So this is going to give me 10 a squared b. Then I have 4 minus 2a squared b, which is going to give me positive 2, right? 4 minus 2 is 2. So this here, if I gather like terms, I have successfully summed them up, right? So I have this entire term is equal to 10a squared b plus 2a squared, 2ab squared. And what we want to now do is we want to look at, so as you can see, we have a binomial, right? So as you can see, options 2 and 3 are false because I have a trinomial, and we don't have a trinomial, we have a binomial. This guy here is a binomial because I have 2 terms. And now we have to figure out, okay, does it have a degree of 2 or a degree of 3 here? And what we can do is we can actually look at, if we want to notice the degree of this of these options here, we can say that our degree here is simply just the sum of the exponents of these guys here. So if I sum these exponents, remember I have imaginary 1 and imaginary 1. So if I sum the exponents, I have 10 here, which has no exponent. A squared has an exponent of 2, and b to the power of 1 has an exponent of 1. So simply 2 plus 1 is equal to 3. So the degree, so therefore I have a degree of 3, which means therefore our solution must be A, right? Because we have a binomial with a degree of 3. So therefore we have a binomial with degree of 3, which means option A is the correct answer. So the solution here is correct. Awesome. So again, that's my 10 problems of the day. Again, thank you so much for watching the stream. Again, my name is Joey. If you like this channel, if you like what I'm doing and what all the other tutors are doing, you can definitely subscribe to our YouTube channel at youtube.com/OneClass, or you can check us out on the main website at oneclass.com/livestream. Again, my name is Joey. Thank you so much for watching. I stream math on Mondays and chemistry on Wednesdays, and you can come check me out then. Again, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.